Hello everyone, this is Mrs. Spivey, and today in this video I'm going to teach you about how to count significant figures as well as round your math answers using the correct number of sig figs. I apologize in advance if you hear background noise. I am at school, so the bell might ring. Don't be alarmed. So to count sig figs, we have a couple of rules that we're going to follow. Okay, rule number one is that all non-zero integers count as significant figures. Okay, all non-zero integers count. So, what's an example of a non-zero integer, or a value that has nothing but non-zero integers in it? Let's try 241. Okay, 241, 2, 4, and 1 are all non-zeros, and so that means that this value has 3 significant figures. Okay, let's try another one. What about 11? 11 is going to have 2 significant figures. Okay, but not all numbers in the world are going to have no zeros in them. So we have to learn how to classify our zeros. Okay, first up is a leading zero. Leading zeros do not count as significant. Okay, so let me give you an example of leading zeros. Okay, all of the zeros that I'm going to underline are considered leading zeros because they come before all of the non-zero integers. So see these as like the engine of a train. Okay, they do not count as significant. Okay, so our sig figs are going to be the 7 and the 2. So this value has 2 sig figs. All right, no matter how many leading zeros you have, none of them count. So 0.0000000000004, just for the sake of being dramatic, is only going to have one significant figure. And that's here. This 4 is the one significant figure. The leading zeros are placeholders. Okay? All right. Number 3. Sandwich zeros count. Okay, so let me give you an example of a sandwich zero. Okay, a sandwich zero is one that is literally in between non-zero integers. No matter where it is, whether there's a decimal or not, if you have a zero that's in between non-zero integers, I call it sandwiched, and they count. So 101 is going to have 3 sig figs, while 730.002, all 3 of these count. Okay, so that gives me 1, 2, 3, 4, 5, 6 sig figs. Now, these zeros right here are not leading zeros like the example we did before. They are in the middle of a larger value. These leading zeros, to reference our examples up top, come before any non-zero integer that you see. Okay? Rule number 4. Trailing zeros count if, this is a big if, there's a decimal. Trailing zeros count if there's a decimal. So let's go through a couple of examples. 2,300. If I estimated that there are 2,300 students in this school, that has 2 sig figs. So you're saying there could be 2,899, right? That would round, oops, sorry, that's too high. 2,299. This is a bad example, sorry. 2 sig figs in that value. If you go around and measure every single student, you count every single student, every single classroom, and everyone happens to be there, you know for a fact that there are 2,300 exactly students. This value is going to have 4 sig figs. Okay, now this decimal is not a typo. Oftentimes you will just see a decimal after a 0 now. It doesn't have to have 0.0. Okay, so if you see a decimal, it counts as a decimal. It's not a typo. So a comma is not the same as a decimal. Okay, so if I have okay, and I'm trying to count the significant figures in this value. I have 2 non-zero integers that I know definitely count. Okay, I have 3 leading zeros that never count. And so now we're going to take a minute to pause on this trailing 0. Okay, this is a trailing 0 and it does count because there's a decimal. So that gives me 3 sig figs. All right, let's try a couple more just random examples off the top of my head. If I have 5,280. All right, you guys look at all of our rules. Count. I'll give you a second. All right, so this is going to have 3 significant figures. Okay, let's try another one. Let's try 72.070. That value is going to have 1, 2, 3, 4, 5 sig figs. Okay. All right. So if you've been absent or you need extra help with counting sig figs, I want you to look at page 34 in the Unit 1 book. Page 34 is your worksheet to go and just practice counting significant figures. Okay. So practice page 34 and then come back and resume the video and you can learn about how to do math with significant figures. All right, so now that you have learned about how to count significant figures, now we're going to talk about how to do math with significant figures. Okay, so there are 2 rules that we need to go over in doing math with significant figures. So the first rule is for multiplying and dividing. Well, wait. Let's instead practice what I mean by rounding. Okay. So I'm on page 35 of your unit book. Well, page 35 of your unit book, and I'm on number 1A. So the instructions say round off each of the following numbers to 3 significant figures. And A says 15.994. Okay, so if I'm trying to round this value to where I only have 3 sig figs, this first 9 is my 3rd sig fig. Okay, I'm going to look directly next door. This 9 bumps it up, and so that is going to give me 16. So that only has 2 sig figs in it. So to get me to 3 sig figs, I'm going to add 0.0. Okay, so we rounded a value to where it has 3 sig figs. Let's try another one. You're like, oh, this is easy, no big deal. You've known how to round for a long time now. Okay, 0.6654, 1B. So 0.6654. My 3rd significant figure is going to be this 5. The 4 is going to leave it alone, so my answer would be 0.665. Okay, this first 0, remember, does not count because it is a leading 0. Okay, now 1C. 1C. 87,550. My 3rd sig fig is going to be this first 5. Okay, the 5 next door bumps it up. And you might want to write 876. Now, this is where you have to think. 87,550 is much bigger than 876. So we need 2 placeholder zeros. But you cannot have a decimal, because then that would change it to 5 significant figures instead of the 3 that my instructions are asking me for. So please be aware that scientific notation is your friend. 550. Okay, 1, 2, 3, 4, 8.755 times 10 to the 4th. It very obviously rounds to 8.76 times 10 to the 4th, which is the exact same as this value. Okay, so in order to round, anytime you add, subtract, or multiply and divide, you have to follow sig fig rules when rounding your answer. Okay, but rounding is just the same as it was before. Okay, if the number is 5 or greater, it'll bump it up. If it's 4 below, you'll leave it alone. Okay, so let me add. Okay, so first up is the rule for multiplication and division. When you multiply and divide, the number of sig figs in your answer is equal to the least number of sig figs put in. So in order to round your answers when you're multiplying and dividing, we have to know how to count sig figs. Okay, so let's look at an example. Get out your calculators with me. If you have, this is just a random problem, 2.6 centimeter times 1.725 centimeters, your calculator would give you 4.4825. Because we're in chemistry class, we definitely care about units. So centimeter times a centimeter is centimeter squared. You're like, great, there's nothing new about that. Okay, the new part is rounding your answer. 2.6 has 2 sig figs, where 1.725 has 4 sig figs. So that means that my answer right here can only have 2 significant figures. So I underline the 4, the 8 will bump it up. So 4.5 centimeters squared would be our final answer. Okay, what if I had 12.30 grams divided by 4.0 milliliters? Okay, type it in your calculator. 12.30 divided by 4.0 gives me 3.075. My units would be grams per milliliter because nothing cancels out. And so then I would count my sig figs. So 12.30 has 4 sig figs. 4.0 has 2 sig figs. And so that means your answer can only have 2 sig figs. So that would give me to 3.1 grams per milliliter. Okay? Now, what if we are adding and subtracting? Well, then you have a different rule. Okay? The rule for when you add and subtract is the number of decimal places in the answer is equal to the least number of decimal places put in. Okay, so when you're adding and subtracting, we only care about decimal places. So that's any number, any value to the right of the decimal, whether it's a 0 or not. Okay, so let's look at an example. If I have 9.80 minus 4.762, My calculator says 5.038. This time I didn't give you units to worry about. Now we have to round, okay? 9.80 has 2 decimal places, whereas 4.762 has 3 decimal places. So that means that my answer can only have 2 decimal places, okay? This 8 will bump the 3 up. So my final answer would be 5.04. All right, so if I have 7.20 plus 1.00007, add it up just like normal. Okay, then when it comes to rounding, we look at decimal places. So that would be here. So my final answer would be 8.20. All right, so if you're working with order of operations, sig figs matter. So if you are working this problem, you'd use the top. Obviously, you simplify your numerator first. Okay, but make special note that this is an addition problem, so I can only have one decimal. So simplify the top, and then you can only have one decimal place in your answer because of this 3 here. I'm going to underline it. Okay, divided by our 42. So 79.51 divided by 42. The answer says 1.893. So I have 3 sig figs on the top. Since I don't need this one anymore, divided by 42 gives me 1.8. So I need 2 sig figs. That would be 1.9 as our answer. Okay. There was one sig fig rule that I didn't mention, and it was for exact numbers. Exact numbers are like our conversion factors that we've been working at this point with our metric system. Okay. Exact numbers have an infinite number of sig figs. So they do not change the rounding. So when you're trying to round your answers and you're using conversion factors, or I'll give you a couple examples of exact numbers, those do not matter when you are trying to round your answer for sig figs. So let's say I'm going to take an average of test grades. So let's say you had a 97.5, and then you didn't do so hot on the next one, you got a 61.2, and then on your last test you got an 85. Okay, when I average those, I would divide by 3. Okay, this 3 would be considered an exact number. So my answer, my average test scores, isn't going to only have 1 sig fig. Okay, I would go off of the sig figs that I put in. Okay, same with our metric conversion. So if you're trying to go 3.4 liters to milliliters, like we've been doing in class, 1 liter is equal to 1,000 milliliters. Okay, so this 1,000 has 1 sig fig, the 1 has 1 sig fig, but this is an exact number. So it's not going to affect how I round my answer. I have to look here at what I put in. So I have 2 sig figs in, I got 2 sig figs out, okay, because these 2 zeros do not count. So if you need more help with sig figs, I would go to your unit book and work on page 35 in your unit book. Okay, specifically number 4 at the bottom has a place where you're rounding your answers with sig figs. But we use sig figs all throughout Chem 1, so we learn them in Unit 1, but then we use them forever and ever. So thank you for joining us, and if you need help, please see one of the Chem Squad teachers. Awesome.